Students, from last class onwards we are discussing about sound. Okay, so in this class let us discuss the characteristics of a sound. Okay, so sound is a mechanical wave, right? Yes or no? So what is mechanical wave? Mechanical wave is nothing but any wave which needs a material medium or mechanically a things to propagate, okay, is called a mechanical wave. Okay, so sound is a sound is a mechanical wave. Mechanical wave is nothing but it needs a material medium. Okay, so it needs material medium mechanically something to propagate is called a mechanical wave. Okay, so sound is a mechanical wave. Clear? So if a mechanical thing is removed, mostly it acts as a mechanical medium, acts as a hair. Okay, if the hair is removed, suppose if we created a vacuum, then can we listen the sound which is made in that vacuum? No. Okay, so it means that sound need a material medium to propagate. If there is absence of any medium, then we cannot listen the sound, means sound cannot propagate in a vacuum. Okay, so can sound propagate in other mediums? Not in a hair, in other mediums? Yes or no? Okay, sound propagates in other mediums. Okay, sound propagates in other medium like solids and liquids. Okay, the sound can be travel as a transversal as well as longitudinal. So in air, what happens, the sound travels in a like rare fractions and compression, right? Here sound is see, here is a elastic in nature, right? That's why these travels in a like a compression and rarefaction, even liquids also. But what about solids? Solids we cannot extend or we cannot change the shape by applying any pressure, right? Yes or no? So in solids sound travels as a transversal wave. Okay, so longitudinal, transversal, you understood the difference, right? In elastic in nature, those the sound travels as a compression and rarefaction in even liquids and solids, but not in a case of solids. Okay, so in gases and liquids it will traverse as a longitudinal. In a solids it will travels as a transversal wave. Okay, clear? So sound can travel transversal or a longitudinal, not always a longitudinal. Okay, so sound can travel transverse or longitudinal. Okay, so why we have ears? Obviously to listen the sound, right? Okay, so these ears, we have ears to calculate the sound from where the sounds are coming from. Okay, so we have two ears, right? Okay, so we can listen the sound coming from right, left, even from back and front, right? So how our brain detects the sound which is coming from either right or left? So we have two ears. These two ears receive the sound, right? Yes or no? After receiving, brain will calculate the time differences of a left and right here. Okay, so which ear received the sound first, it will calculate and it will identify from suppose the brain calculated the time differences. So from the right side, sound received in a few seconds. Okay, so then few seconds faster than the left ear. So the brain decides that sound is coming from the right side. Okay, like this brain will calculate the time differences and it will identify the sound whether it is coming from right or left and decides the direction. Okay, so suppose we usually listen the words like talk in a low volume, high volume, in a case of TV players. Okay, TV and speakers. Okay, so we'll talk about the volume. Okay, loud or loudness, right? Yes or no? So next, and also we'll talk about pitch also. We'll mention it is a low pitch voice, it is high pitch voice, it is medium pitch and medium bass, like that, right? So what are these volume and pitch? Okay, so let us discuss. So we already discussed sound travels as a wave, right? Yes or no? Okay, so okay, sound travels as a wave. Okay, so compression is nothing but high pressure, right? That is equal to crust. Okay, crust, high pressure. Trough means low pressure or valley. Okay, so crust means here compression. Okay, so trough means it is rarefaction. Okay, so here the distance between two crust or two trough is called a wavelength. Okay, so what is wavelength? Difference between a distance between so what is wavelength? So what is wavelength? Distance between two crust or trough is called a wavelength. Okay, so what is frequency? Frequency is nothing but number of crust and trough in a one unit. Okay, so frequency, number of crust and trough both together. Okay, in a unit time or 1 second. Unit time is called a frequency. Okay, so number of crust and trough in a one in unit time, that is 1 second, is called a frequency. Okay, so next, what is time period? So time period, time taken by one wave. Time taken by one wave is called a time period. So time period is equal to 1 by frequency. Suppose five waves will see in 1 second, five waves. Okay, so let us say five waves in 1 second. So one wave in 1 by 5, right? Yes or no? 1 by 5, right? So this is a unitary method. Suppose one pen cost 5 rupees, means for 20 rupees how many pens you will get? 5 pens cost is 20 rupees, for 1 pen cost 4 rupees. So that is unitary method, right? So in the same case, 5 waves in 1 second means 1 wave in 1 by 5th second. So time period is equal to 1 by frequency, frequency is equal to 1 by time period. Okay, so these are inversely proportional. Okay, so these two are inversely proportional. So next, what is amplitude? So maximum displacement, so this is called mean position. Okay, so mean position, these maximum displacement, suppose if the pressure is very high, in that case what happens, these will increases. Okay, yes or no? Like this amplitude increases. Okay, these, it is going high from the mean position, right? So that is called amplitude. Amplitude is nothing but maximum displacement from mean position. Okay, so maximum displacement from the mean position is called amplitude. Okay, so this is amplitude. So if we increase the value more and more, that amplitude will increases. Okay, if you are talking about volume is nothing but we are talking about amplitude. Okay, not frequency. Okay, so if you increase more and more value means you are increasing the amplitude. Yes or no? Okay, so what is pitch? So what is pitch? Pitch is nothing but number of waves are increasing in second. Okay, number of waves increasing is nothing but wavelength decreases, wavelength reduces or decreases, and frequency increases. Okay, so this is a case of a high pitch. So let us see. So you have observed here, this is high pitch. So try to observe, wavelength is reduced. Here observe, the wavelength is increased. This is low pitch. Means waves are increasing. Okay, here waves are increasing. Here waves are increased, and here waves are decreased, means compressed. In this case wavelength is high and wavelength is wavelength is low and wavelength is high. Means here these wavelength is increasing more and more, means it is a low pitch. Here it is high pitch. Okay, so if we are talking about pitch, means that is related to frequency. Okay, so we are talking about volume is nothing but amplitude. Okay, so amplitude is nothing but we are talking about a value, and pitch we are talking about frequency. Okay, so take a particular instrument like a guitar or jaltarang. Okay, so what is tone? One frequency. Okay, so what is tone? Tone is nothing but they are talk about tone, right? So tone means one frequency. Okay, so you can they talk like if you are from a musical background, you understood the what is tone, what is undertone, and what is overtone, right? Yes or no? So tone is nothing but one frequency. So note means some frequencies together is called a note. Okay, so tone means one frequency, note means some frequencies together. Okay, so these are high and low pitches. Okay, so you can observe while playing any musical instrument. Okay, so see, while playing a jaltarang, water, see, we already discussed about jaltarang, right? So filled with the water and of different levels. Okay, see, here we are differentiating the air column, right? Yes or no? Okay, so here we can listen the different sounds, means here is amplitude is varying or frequency. Here frequency is varied, means pitch is different. Okay, so the amount of air is available here is different, means pitch is different. Okay, so in guitar also you can see the thickness, strings of the thickness is different. Here the sound made by these different instrument, pitch is different, means here frequency is different, not a amplitude. Okay, means volume is not different, just pitch is different. Okay, if you try to do this and try to observe, depending on the air column available for these, the pitch is increases or decreases, let us find. Okay, if the air column is more, then the pitch is more. Okay, air column is less, the pitch is different. Okay, so here frequency is varying, means pitch is different, not a value or amplitude. Okay, so one more class is there on this sound chapter. That's all in this class. So try to do your worksheet. It will be available from after 1 and before 3:30. Okay, thank you.